Hi, my name is Katie Gamanji, and I am a cloud platform engineer for Condé Nast. Around 1.5 years ago, I joined Condé Nast to contribute to a project that aims to create a centralized, globally distributed platform that has Kubernetes at its centerpiece. Today, I would like to talk to you about Kubernetes Scalability, and more specifically about federation and cluster API. I would like to start by giving an introduction of what Condé Nast does, and more specifically, what our platform is and infrastructure. I'm going to follow by giving an introduction about federation and how exactly we can manage multiple applications into multiple clusters. And I'm going to finish by giving an introduction of Cluster API and how we're actually prototyping this at the moment to have a more efficient and effective way to actually create our clusters. So, without any further ado, I would like to introduce you Condé Nast. Now, Condé Nast has set a benchmark for print and digital publishing for more than 110 years. We operate brands that are fashion and luxury oriented, and you might be familiar with some of the brands like Vogue, GQ, Wired, Vanity Fair, AD, and many more. These are just a few of the brands we have in our portfolio. Currently, we have 38 brands, and we distribute them in 26 languages. Quite an inclusive range of products. With headquarters in London and New York, we operate on an international scale in more than 12 countries. We have 86 websites overall, and they generate more than 330 million unique users every single month. So far, we reach a total of 1.6 billion page views every single month. This means that every single minute, we're going to deliver 37,000 articles to our users. It's quite a considerable customer base we have out there. Now, I mentioned that we operate in 12 areas. However, if you look at the map, you can see that the areas are quite geographically dispersed. Historically, all the market had quite a tailored and individualized tech stack with very little shared components in between them. This includes the systems to deliver the live traffic, as well as the systems to write the CMS content. Another inconsistency for us was the visual in design, as it made it difficult for us to provide a unified experience for all our customers. As such, 2 years ago, we kicked off a digital transformation project that aims to create one global platform, and more importantly, we distributed it globally across 5 different regions. We have currently, we aim to have 9 clusters, but currently we have 7 clusters. We still to create our Chinese clusters. So we have 3 clusters in Europe, a dev, staging, and production one, to deliver the content for our European markets. The cluster in Tokyo is going to focus on the Taiwanese, Japanese, and Indian customers, while the cluster in North Virginia is going to deliver the content for our Mexican market. China alone will have 2 dedicated clusters, a staging and a production one, while in Dublin we have 2 more clusters to host our internal tools. Now, if you look at the map, you'll be able to see that in Russia, we do not have a replica of our tech stack. This is because the current strategy is to deliver the content from our European servers while having a CDN, which is Russian-oriented. This will ensure our service availability in Russia while investing minimal engineering effort. Our platform is live since October last year when we first launched GQ France. Since then, we migrated 2/3 of our intended estate, and we serve more than 250 million page views every single month. So it's quite a considerable accumulated amount of requests we serve from our backend systems. Now, currently we have 7 clusters. The way we actually deploy our applications to the clusters is we have the same stages repeated in every single pipeline for every single region. So it's not necessarily ineffective, but it's quite tedious because if you have to deploy change, you have to deploy it to all the pipelines, to all regions. So we started to think, is there a more efficient way to deploy our applications to all regions, considering that they're quite similar? There's very little discrepancy or difference between the settings. So we stumbled upon federation. So what exactly is federation? It's a mechanism to provide a management, it's a mechanism to provide one way or one practice to distribute application and services to multiple clusters. One point I would like to take across is federation is not about cluster management, it's about application management. I'm going to repeat this a couple of times throughout because I think this is a very important thing to take away. When we're talking about federation, we talk about SIG multi-cluster. Currently, Federation is in alpha release and requires a Kubernetes 1.13 to run. Having a V2 means that there is a V2 on at some point. Now, V1 is deprecated and no longer under active development. Historically, when they actually tried to create the Federation V1, they tried to wire the code for Federation in the Kubernetes code base. This was, again, not efficient because most of the time they had to keep up with all the changes and all the releases. It was not a way to move forward. So in V2, they changed completely the way they actually create Federation. They make use of the Kubernetes APIs, and they're going to make the best use of customer source definitions, or CRDs. They're using the building block principle. Another project from Federation I would like to mention, from SIG multi-cluster actually, is cluster registry. Now, cluster registry is very tightly coupled with Federation. It contains all the metadata and configuration necessary to connect to clusters, and I'm going to mention this later on. Now, let's look exactly how Federation works. Supposedly, we have a number of clusters in different regions, and we would like to deploy an application to all of these clusters. The way Federation is going to work, we're going to have a host cluster, and we're going to have member clusters. So everyone would like to push the configuration, that's going to be known as the member cluster. On the host cluster, we're going to have the cluster registry and the federated API installed in it. Now, with the cluster registry, that means that the host is going to have all the information to connect to the member clusters. And with the federated APIs, we actually require all the controllers running on our host clusters to make sure we reconcile our federated resources. In a nutshell, the host cluster is going to be acting as a control plane, and it's going to actually propagate and push configuration to the member clusters. If we talk about Federation manifest, there are 2 points of information we need to provide. There's going to be the cluster placement and the configuration overrides. With the cluster placement, we have to say exactly where we want our application to be deployed, onto which member clusters. In the configuration overrides, we'll be able to change any configuration and tailor our application to the cluster if need be. Now let's look a bit more into these 2 configuration options. With the cluster placement, Federation allows us 2 fields that we can use to say where the application should be running. We have cluster and cluster selector. Now with the cluster, we have a declarative list of the cluster names. So in this particular case, an example, we say that we want our application to be deployed in cluster 2 and cluster 1. With the cluster selector, we have the capability to make use of the labeling system in Kubernetes, which is quite a powerful mechanism in itself. In this particular case, we say that we want to run our application with a cluster that are tagged with the label region EU Central 1. So this, for example, is going to be running only on the European servers. It is worth to mention at this moment that both of these fields can be specified. So in your manifest, you can have the cluster and cluster selector. However, cluster is going to have precedence over the cluster selector. So if you have your cluster being empty with an empty value, and you have your cluster selector with a bunch of values, that's going to be ignored because this has precedence and it's empty. This is quite a nice takeaway from these manifests. With the configuration overrides, we'll be able to replace, add, or remove any configuration. So pretty much we'll be able to tailor our application to a specific cluster. To do so, we need to say where we would like the change to be, in which cluster, and what exactly we would like to change, so what field specifically. In this particular case, we say that we want to override the amount of replicas to 5 in cluster 1. If you take all of this together, this is how a federated resource is going to look like. So this is a federated deployment. I shortened it purposely because in the spec, we have pretty much is going to be the spec of a deployment. There's no changes over there. However, we're going to add the 2 bits of information I mentioned before, the placement and the overrides. So in this particular case, we have an Nginx deployment, and we would like 3 replicas for this specific deployment. We want it to be propagated in cluster 2 and cluster 1, and then we say in cluster 2, we would like 7 replicas as opposed to 3. So the end result is going to be, in cluster 1, we're going to have an Nginx deployment of 3 replicas, And in cluster 2, we're going to have an Nginx deployment with 7 replicas. And I think it's time for the demo. So we're going to actually look how federation works in action. And hopefully everything is still up and running. Can everyone see? Can everyone in the back see? Is it good? Awesome. Now, I've already have a working example of federation. So what I've done here is I have 2 clusters, cluster 1 and cluster 2, and you'll be able to see them here. I've already have installed the cluster registry as well, which means I have all the necessary metadata, so like kube config files or API tokens to connect to my clusters. So in the status here, you actually see that we are ready. So we can actually push configuration to our clusters. Now, what I would like to do actually in the demo today, I'm going to federate one namespace, and then I'm going to federate a deployment across 2 clusters with different changes between them. So first of all, let's look at one of our federated namespace. Right, just one sec. Oof. So this is our federated namespace. Now, the kind is going to be federated namespace. We give it a name. It's going to be test namespace. And we say placement. We want for this namespace to be propagated in cluster 1 and cluster 2. Now, let's apply this particular manifest. So I'm going to do a kubectl apply -f, this particular file. Ooh. Spelling during demos. Now, if I do a kubectl get namespaces in my cluster 1, I'll be able to see a test namespace. Actually, I've created this previously. However, if I look in cluster 2, where it's actually going to be federated, we see that we have a new test namespace, and it's been created 16 seconds ago. Right, this has been quite straightforward. Now let's look at a federated deployment. So pretty much what we had previously in the slides, but with slight changes and additions. So a federated deployment. So as mentioned before, the federated deployment is the kind. We want an Nginx deployment, and we have image over here, an Nginx deployment, and we want 3 replicas for our deployment. So very straightforward. I'm not going to focus too much on the spec part over here. However, what I would like to mention here is the placement. So here we say that we want to, oh, that's not good. I'm not going to use that. We want to have it in cluster 1 and cluster 2, but I would like to focus on the override specifically. So what we say is like we want to tailor our application in cluster 2, and we say instead of 3 replicas, we want 5. We want to use a different version of Nginx, so we're going to use 1.17 Alpine image rather than the latest. As well, we're going to add some annotations to our application, a very simple one, which is going to be foo bar. Before I apply this, I actually want to look into my clusters to see if this deployment exists. So I'm going to do a kubectl get deployments. Yes, in our test namespace. And I would like to look into cluster 1. So I have nothing there, which is supposed to be because we didn't deploy anything. And the same happens in cluster 2. So I have no deployments. Let's apply our federated deployment. So I'm going to do a kubectl apply our federated deployment file. It has been deployed. Now, if I look again in cluster 1, I'll be able to see that I have a test deployment, which is going to be our Nginx deployment with 3 replicas. If I look in our cluster 2, I'll be able to see the same deployment, but with 5 replicas, because we actually overwritten the value for that. But we actually changed 2 more things, the image and the annotation. So I'm going to go back to cluster 1. I'm going to get the YAML of this particular deployment, and I'm going to grab the image. So in cluster 1, as specified, we're going to use the latest version of Nginx. However, if I do the same command in cluster 2, I'll be able to see that it has been overwritten, and we use 117 instead. However, this is not it. We actually changed our annotations as well. So let's grab the annotations in cluster 1. So I'm going to grab 3 lines after. I have my annotations, and I have just a deployment revision version, which is added by default. If I issue the same command in cluster 2, I'll be able to see that we added our annotation full bar as well. So this is a way of how we can actually tailor our application to every single cluster, but at the same time have that centralized mechanism to push deployments and services to the application, to the clusters. Right. This kind of concludes our demo for federation. However, before I move forward, I would like to leave you with a few takeaways about federation. One important thing, which I mentioned before, and I would like to mention it again, federation is about resource management. It is not about cluster management. It's how you manage multiple applications into multiple clusters. It is not about how you manage multiple clusters. This is going to be coming in the second part of the talk, which is the cluster API. Another feature for federation is the namespace scoped control plane. Now, in this example particularly, we used an entire cluster to act as our host cluster. And we have actual clusters, like full-fledged clusters for our members. With namespace scope control plane, we can use just one namespace, so we can federate the namespace across different clusters. This is quite a powerful mechanism if you'd like to use federation in production, but not dedicate an entire cluster to it. You just dedicate one namespace. Another thing about federation is conditional scalability. This is actually quite a tricky thing about federation. Now, the source of truth for our federated deployment is going to be within the host cluster. Supposedly, you have a deployment, and you have, for example, 5 replicas. You have an HPA object on top. This means that you're going to scale the amount of replicas up and down. If we do that, for example, if the HPA will modify the amount of replicas from 5 to 10, that particular change is not going to be retained. This is because the source of truth is within the federated namespace. Federation actually allows a retention flag, which will allow you to keep the amount of replicas or any changes you do to your deployment. So if you'd like to do so, you have to use the specified flags for it. And another thing about federation, which is actually what makes it such an important and effective project, it has the higher level behavior. Now, with federation, we have quite a sophisticated scheduling mechanism. This means that if you would like to have 100 replicas of your application running around all your clusters, the scheduler would be able to do that. If your cluster goes down, for example, one of the clusters, the scheduler will have the information and make sure you have 100 pods running at all time. So it's actually clever enough to figure that out. Again, with federation, it's a very good mechanism to migrate your application from cluster to cluster because it has this higher level behavior. It will see that we have unavailable clusters, we're going to move it there if need be. And another thing from the higher level behavior is the ingress and the DNS. Now, federation comes with a very powerful service discovery, which will allow you to get all the endpoints of your application from all the clusters by having this one global endpoint. Right, so we talked about how can you manage multiple applications into multiple clusters. However, at Condé Nast, we're actually thinking how can we deliver our clusters more efficiently, or let's say in a more modern way as well. Before I move to cluster API and talk about it, I would like to give you a use case of where exactly we can integrate this tool within Condé Nast. Now, Kubernetes underpins the entire infrastructure of Condé Nast. We are a CoreOS house, meaning that we're using Tectonic installer for our cluster deployment, and we're going to use etcd for the storage of our cluster data. Using Tectonic allows us to plug in into different cloud providers while consuming the compute and networking resources while being cloud agnostic. As such, we can deploy 100% open source Kubernetes in a multi-master, multi-node fashion. Again, actually, I would like to mention China and Russia. These 2 regions are actually quite important for us, and I'm going to explain why. Now, from these 2 regions, we have 60 million unique users every single month, and they generate 20% of our entire digital readership. It's quite a considerable customer base, and we have to be prepared technically to meet the demand in these areas. However, deploying to countries like Russia and China can be quite challenging from an infrastructure standpoint. When we kicked off the project for one global platform, we did not have a clear vision of one cloud provider, or that's going to be used for all platforms in all regions. As such, this enforces our decision to go with a self-hosted Kubernetes solution. This means that we're going to manage our own clusters. That means upgrades and any lifecycle processes that we need for our clusters. As well, it will allow our lift and shift capability. This means that we'll be able to, for example, in China, if we have a different cloud provider, we'll be able to lift and shift our infrastructure as long as we have some compute over there. So, actually moving forward into Cluster API, I would like to talk a bit more about the Kubernetes Bootstrap Tools. We have a bunch of them available at the moment, and all of them are under active development. We have kubeadm, kubespray, kops, Tectonic. Tectonic, we actually use it. However, moving forward, Tectonic is no longer under active development. It's actually kind of a gray area over there. It is still available, however, it's going to be merged with OpenShift Container Platform, and it's not something we want to use in the future. Hence, we actually have to revise how we're going to distribute our clusters. And this is why we came across Cluster API. So what Cluster API is, it will provide this unified set of APIs to create, manage, delete, and maintain your clusters by using one interface, which is a common interface, and having minimal changes to your manifest files, as we're going to see later on in the demo. When we talk about Cluster API, we talk about SIG Cluster Lifecycle. It had its first initial release in April 2019, so it's been around for half a year. Not too long, but pretty much enough. Currently, we have the V1 Alpha to release for Federation, and they are very, very close to release the V1 Alpha 3. I was talking about Cluster API, that it provides this unified interface to interact with different cloud providers. Currently, it integrates with around 12 cloud providers, including GCP, AWS, Baidu Cloud, which is a Chinese provider, which will allow us to create our clusters in the same kind of unified manner. And we have DigitalOcean, Bare Metal, and many more. The list goes on and on. Now, how exactly Cluster API works? Supposedly, we'd like to create an amount of clusters in different regions in different cloud providers. The way Cluster API works, we're going to have a management cluster, and we're going to have our intended to be created clusters perceived as target clusters. Into the management clusters, we'll require our controller managers up and running. At minimum, we'll require 3 of them. Now, let's look a bit more into them. So in terms of the controller managers, we'll require the Cluster API CRDS. So these are going to be all the controllers necessary to make sure that we to make sure that we actually have the lifecycle of our CRDs up and running. Another thing we'd require is the infrastructure bootstrap. Now, currently we have Talus and kubeadm available. This particular component is going to make sure that an instance in any cloud provider and any infrastructure provider is going to be added to the cluster as a node or as a master or worker. And the infrastructure provider, there's going to be a different provider for every single cloud provider, which is kind of quite a logical step. And this particular controller is going to make sure to interact with all the APIs of the infrastructure provider. So for example, with AWS, it will actually talk with AWS and provision the actual infrastructure. Once we have our management clusters with all the required dependencies, we'll be able to provision our target clusters. These are going to be our result clusters. It is worth to mention at this moment that the management cluster can be, well, depends. If you're testing, then you can create an ephemeral cluster. Usually it's recommended to use kind, which is an easy way to provision your clusters on your local machine. One command and you have a cluster. You can use that with all the control managers and actually start testing with Cluster API. If you'd like to use Cluster API in production, then you require a production-ready cluster. So this is something to keep in mind. It's quite important to make sure that we have a very solid failover mechanism. I've mentioned the Cluster API CRDs, and I would like to mention them a bit more in detail now. We have 4 customer service definitions for Cluster API. We have cluster, machine, machine set, and machine deployment. The cluster is going to have all the information required to kind of an abstract layer on top of our clusters. We're going to have information such as the CIDR blocks for our services and pods. The machine resource is going to be very similar to a node resource. So we'll be able to provide information of our version of Kubernetes we want to run. As well, we'd be able to say for our infrastructure provider what kind of instance we want, if you want it in a particular region, if you want to attach any IAM policies on top of that. The machine set is going to be very similar to replica set. This means that it will make sure that an amount of machine resources is going to be up and running at all time. And the machine deployment is very similar to deployment, pretty much. It will make sure that has this rolling out strategy, which is quite powerful within Kubernetes, and make sure that you have your instances up and running with minimal downtime. It is worth to mention at this moment that the machine resources are immutable for cluster API. This means that if you have a new version or like new configuration for your instances, the machine is actually going to be removed. It's not going to be patched. It's going to be removed, and then you're going to have a new instance added to your deployment. And if I'm not mistaken, it's part for a different demo. So let's make sure everything is up and running. So what I actually have here, I already have quite a few bits pre-installed just to make sure that everything is going to be quite quicker to demonstrate. So currently I have a kind cluster on a VM, and in the kind cluster I have the free controller managers. So what I actually have here is the cluster API CRDS, and this is going to be provided by this one, so cluster API. As well, I do have the cluster API AWS. I know the naming is quite interesting, but the A over here, that means it's AWS. So this is going to be the infrastructure provider for AWS. I actually have one for Docker, but I'm not going to show the Docker clusters today because I need to restart some bits of my machine, but I'm going to show you the AWS one. And another thing I would like to show, there is a lot of things happening here. We have as well the the Bootstrap provider, which is going to be kubeadm. So let me just kubectl get namespaces. And that's going to be this one. And this is going to be the controller for our Bootstrap provider, which is going to be kubeadm. Now, what I would like to actually show you is how to create a cluster, and we're going to add some instances to our clusters. To do so, let's first look at our cluster resource in AWS. So this is how it's going to look like. What we actually specify here is the kind of higher level information about our cluster. We say that, for example, our CIDR pods is 192.168.0.0/16. That's going to be our subnet for that. Another thing I would like to mention here specifically is the infrastructure reference. So this is how we say that this particular cluster, so this is the cluster configuration. This is going to be the same for our different infrastructure providers. However, the infrastructure reference is what's going to be different. So what we say here is we want an infrastructure to be provided to be issued in AWS. So we have a kind AWS cluster. And this is actually declared over here. So what we say is we want a cluster with cluster API AWS name to be provisioned in EU Central 1 region, and we want to attach a specific SSH key pair for that specific instance. So the name of that key pair is going to be Kate's Bonsai. I've actually issued that because as part of this particular resource, we're going to create the VPC, we're going to create the subnet, and it can take a while to do so. As well, it will create a Bastion instance, which makes sure that once we create the cluster, the Bastion is going to ensure that we actually receive external traffic. Now, if I do a kubectl get clusters, I'll be able, ignore the Docker one for now, we actually have our cluster API AWS provisioned. If I describe this, I'll be able to see that I already have an endpoint for our API servers. This is going to be a load balancer, and we have a port provisioned for that. Before I move to, so we have like the higher level behavior. Now let's create the control plane or the master instances. I'm going to apply this because it takes maybe 1 or 2 minutes to provision that, and then we're going to look at the file. So I'm going to quickly do a kubectl apply AWS control plane. So while this is created, let's look at the file. Now this is a bit more verbose because the machine instance has a little bit more configuration we need to add to this. But it's very straightforward. Like we've already mentioned the controller managers and we've already mentioned the points of information we need. So what we say here is we want a machine resource. We want to add it to a specific cluster by using the labels. I'm not going to focus too much on that. However, here we say what version of Kubernetes we want to run. So it's going to be 1.15.3. Next, we're going to have our Bootstrap configuration. So this is actually going to be sent to our Bootstrap provider, and this is actually create an instance and add it to the cluster. Now, if you look at the Bootstrap provider, which is slightly down over here, ooh, too much down. So this is our Bootstrap configuration. As mentioned, we have kubeadm Bootstrap provider installed. What we actually say here, I'm not going to go too much in details, but we specify our cloud provider, which is going to be AWS, but more importantly, we specify an init configuration. So this will actually invoke a kubeadm init operation on top of it. And another bit of information we're going to add to our machine resource is going to be the infrastructure reference. So this again is going to be in AWS, and we say we want an AWS machine. And if you look at the actual reference, just over here, we'll be able to see that we want an instant type to be T3 large. We want to attach a specific IAM role to our instance. So if you want to make it, close down to the world or like have security in mind, you can definitely do that. As well, we have an SSH key attached to the instance. So which is going to be the same. You can have a different one for your masters and for your workers if need be. Now, we've deployed that. What actually this should give us is when we do a kubectl get machines, we'd be able to see our instance. However, if my session in AWS is still active, I'll be able to show you the actual instance that has been created. Right, let me just zoom this a bit. So it's actually still initializing. It's being created right now. So once we create it, it's going to be our master instance. However, if we'd like to connect to our clusters, right, this is going to be... So the way Cluster API works is you create your cluster, and it's going to create a secret with the kubeconfig of how to actually connect to that particular cluster. So actually, if I do... Slightly nervous. Let's see if this works. So we want our AWS kubeconfig, and we want to save that in locally on AWS. Right. Now, supposedly we want to get our, ooh, that didn't work very well. Right, is it because it's still issuing? No, it's been provisioned. Well, let's try again. It doesn't work. Well, we actually can see that our instance was provided. I have a recorded demo, but I'm not sure if you have time, but if you do, I'm going to show you. So we have the control plane. This is going to be a master instance. What I wanted to actually show you while connecting to the cluster is that all our nodes are going to be in not ready state. This is because we don't have a networking component installed on it. So once we install Calico into our new cluster, we'll be able to connect to it and have deployments and applications going on over there. And let's look into the next bit we'd like to show you is the actual workers. So if you'd like to add workers to our cluster, we're actually going to use a machine deployment in this particular case because we'd like more replicas of the same resource. So here we say that we want 2 replicas, or 2 workers actually. We attach it to our cluster by using labels. I'm not going to focus on that. However, I am going to focus on the spec section. So again, here we have a specific version for our Kubernetes. We want 1.15.3. We attach a specific Bootstrap configuration. Now, if you look at the Bootstrap configuration, we'll be able to see that we have a joint operation. So this will invoke a kubeadm join to attach a worker node to your existing cluster. And another thing we have for our machine deployment is the infrastructure reference. And in this particular case, we have a slight difference. We want our worker nodes to be a T2 micro rather than T2, I think we used a T2 large. Yeah, T3 large. So we can actually specify different instance types for our applications. Right. Oh, I think I'm running over time. Oh, sorry. So just moving forward, I would like to leave you with a few takeaways about Cluster API. Now, Cluster API has been so effective and efficient in such a short amount of time because it uses the building blocks principle. It actually makes the best use of Kubernetes API endpoints rather than creating new endpoints for that. Another thing about Cluster API which makes it so important for us is the fact that it's cloud agnostic. We'll be able to have one common interface to deploy clusters into different infrastructure providers with minimal changes to our manifests. And another thing about Cluster API is that it's still experimental. It's in alpha release, it's been around for half a year. However, if you have a usage for Cluster API, please try it and please file any issues or any bugs you find, because now is the time for you to customize Cluster API for the future. And the same goes with federation. So in conclusion, very, very shortly, today we talked about what our platform at Condé Nast is. And more importantly, we have specified use cases of how federation can be used within the Condé Nast ecosystem. Another thing we talked about was how Cluster API can be used to deliver multiple clusters by having a common interface. These are just a few of the references. If you'd like to get to know more about these tools, I've written 2 articles on how to get started. So pretty much what I talked today, you can have it in writing as well, with a few kind of practical bit as well. And yes, if you'd like to work with us, please visit the link provided here. I'm going to be available on social media to answer any questions you have. I'm a bit over time, but I'll be available still after the talk to answer any questions. Thank you.